Hey, hello, it is me, John Park, and it is time for another episode of JP's Product Pick of the Week. Thank you all so much for stopping by and for your patience as my entire internet melted down or something. And I also don't seem to have audio loop-through feedback happening, so raise your hand if the audio goes out. I won't necessarily be able to tell. I can't hear any audio coming through my machine, so that's a big fun party. Woo! All right, so let's see. First of all, I'll say, let me see if I fixed this right here. We've got our Discord up. Hey, yeah, look, there it is. And I also have the chat open over on YouTube, so thanks everyone who has stopped by in both of our chats. If you're wondering where the chat is and you're over on Twitch or somewhere else, check out our Discord. You can go to adafruit.it/discord and then jump into our live broadcast chat channel where there is a dancing cat GIF, among other things. Oh, wow, that thing can really break dance. How about that? So let me not hover on that so it won't distract me. Yeah, a little choppy internet. Looks like it. Yeah, I'm seeing some dropped frames here and there. Unfortunately, I'm so sorry. It's a endlessly difficult troubleshooting mission to get this video streaming well. So let's see. The next thing I'll mention is that this very show is happening inside of the product page for this week's product pick. So if you want, head over to that QR code or that URL right there, jump into the product page, and you will be able to still watch this video inside of there, but you will notice that we have a tremendous discount on this week's product pick. But before I go any further into it, why don't we have Lady Ada tell us a little about this product from when it was launched. Take it away, Lady Ada.
A lot of people like to use the CCS 811. It was a very popular air quality sensor from ScioSense AMS, and it was discontinued over the COVID break. It was revised a couple times and discontinued. Very sad. However, it was replaced. The CCS 811 is now known as the ENS160. It is a greatly improved sensor. It still does effective CO2. It does total volatile organic compounds. It also has air quality. It has inside of it 4 individual MOX sensors, and it kind of uses the combination of them to do the algorithmic stuff. What's really nice is you don't need any weird firmware binary blobs. It does emit the data over I2C as just very easily, so I was able to port this to Python and CircuitPython. One thing I'll note is it has both I2C and SPI interface. However, the ScioSense Arduino library and the CircuitPython library does not support SPI at this time. I'm sure it does work, but we test all the pins, but only I2C interface is used right now. We might eventually add SPI as well later. Hold on. I will now drop something.
That's right.
And now I can...
we can confirm gravity is still working here.
All right, so here you go. Here's just a quick demo. What is that? Another nice thing about this sensor is that you can calibrate it with temperature and humidity. So these sensors are affected by temperature and humidity because the wetness, the dampness of the humidity will land on the MOX sensors and change the resistance, which means that as the humidity rises, it'll think that there is more organic compounds, or it'll think there's more CO2. However, you can, if you have a separate temperature humidity sensor, there's functions that you can tell it, here's what the humidity and temperature is in the area, and it will use that to calibrate and fix the output. Basically, like most MOX sensors, they're not calibrated, so, it is effective CO2. It's not a true CO2 sensor. It's a basic air quality indicator. It does a fairly good job of detecting alcohols and stuff, but, it's not going to compare with a $60 CO2 sensor, so just be aware. That said, for the price, which is about $20, it's a very nice sensor, and it's a nice upgrade to the CCS 811. And for everyday indoor air quality measurements, it does a very good job.
Yeah, probably not a bad idea to have these around.
Yes, not a bad idea at all. In fact, this right here, look at this little beauty. This is my product pick of the week this week. It is the ENS160 MOX gas sensor with Stemma QT. This is a delightful little gas sensor, an air quality sensor, particularly for indoor air quality, that you can use over I2C with any of your microcontroller projects using a Stemma QT cable to plug that in. And in fact, I'm going to go ahead and plug one in right now. I'll show you a neat little setup I've got here. This is a QT Py with a long Stemma QT cable. I'm going to simply plug those in like so. Throw this in the overhead here so you can take a look at this. And I've just stuck that on a piece of blue tack so it doesn't go dancing around. So here is my QT Py plugged in over I2C to the ENS160 gas sensor. Plug that in. And now what I'll do is, let's jump over to, oh, it broke. No, that's not the right one. Okay, that's not actually broken. That was me. I'm the one who did that. Where's the what I'm looking for? Hey, all right, well, I guess I will. Oh, wait, this will work. Sorry, software went haywire. Hey, look, that's it. That's what I wanted to show. Put one of these right here. Stand by. Okay, good. Demo's good and ready. Okay, so here we have the ENS160 MOX gas sensor. It's plugged in with a Stemma QT cable over I2C to a QT Py right there. I'm running a little bit of CircuitPython code right now. This will also run under Arduino. And you can see I have a little readout here showing air quality index. It spits out that value. The total voltaic organic compounds, it's I think in parts per billion, so we have about 26, 30 or so. And then the CO2 level, which is parts per million, which is hovering around 420. So this is a largish space, was well-ish ventilated till I closed the main door. But you can see I've got a nice quality of air. We can do a couple of things to test it out, though. First of all, let's say we're in a much smaller space and we want to test CO2. I'm just going to breathe on it from pretty nearby. You'll see that level start jumping up there. My CO2 levels jumped up to, what, 1,000 or so. Air quality is going to have to rebound after that. But before I give it too much of a chance to rebound, I'm going to stink it up with this paint marker. So you can use this for, watch these values here. I'm just setting this paint marker. Wow, the total, oh my gosh, volatile compounds was jumping up in the 5,000s there when this first landed. And I think this had just a bunch of vapors capped up in there that came off. I would have to shake it up and wet the tip to get a lot. But even just that first release of the fumes coming off of there, that's why some of these markers smell pretty strongly. This will detect that as well. If you look in my code here, you can see how simple it is to use. I'm importing the ENS160 library. I'm setting it up on the I2C bus. And then we have the temperature and humidity compensation. So if you know these values, or roughly these values for the environment you're testing, you can give it a higher degree of accuracy for the sensor itself because it can compensate for those values. So this is in centigrade and the percent humidity. And then the only thing that I'm doing is just querying the sensor. So ENS, that's the object I created, ENS.AQI gives me air quality, ENS.TVOC gives me the total, not voltaic, why do I say voltaic? Total volatile organic compounds, woo! And then ECO2 gives me the CO2 levels. That's it, all you have to do. The Arduino library runs in a pretty similar fashion. They've got a terrific product sheet here, or data sheet here. If you head to the Learn Guide, in fact, let me go backwards one step so you can see where I got, how I got here. So if we head to the Learn Guide, last page of the Learn Guide, Liz Clark put this Learn Guide together for us. Thank you, Liz. If you check out the Files section, we will usually put a data sheet link. This one links to the PDF for the sensor itself. And this will tell you a bunch of interesting facts about it. I made some notes right. So this is from Sciosense. It's a metal oxide plate, which has a little heater in it and 4 different gas chambers to check the resistance levels. It's temperature and humidity compensated, runs over I2C, can detect the volatile organic compounds such as ethanol, toluene, acetone, hydrogen, nitrogen dioxide. There's a list in here of some of the ones that they happen to call out, but there are many, many VOCs you can measure, as well as CO2. And it has a high immunity to humidity. They mention that, so that's particularly helpful in humid environments. It can still give you an accurate reading, particularly if you use the compensation in your code. And in their uses in the data sheet, they mentioned this is good for an air quality detection, indoor air quality detection, cooker hoods, air cleaners and purifiers, as well as, of course, IoT things. So you can hook this up and use it with things like our Adafruit I/O or other IoT services so that you can keep an eye on the air quality in a particular location. If you take a look over on the page here, you can see we've got half off right now, so 50% off, and you don't need any codes or anything like that. Just throw it in your cart. It's a maximum of 10 per customer, so if you have a lot of, let's say, building spaces that you want to keep track of, this might be a good time to stock up on a few of these, and you can use it with something like maybe the ESP, one of the ESP32 versions of a Feather to do Wi-Fi. Or if you want to do this over Bluetooth, you could use an RF52 board. And what else? Yeah, 10 per customer. Throw them in your cart and you'll get them. So long as you order them before the show is over. We have a little bit of a grace period at the end there, but since we don't need a coupon code for it, we just simply have the price reset. Jelly will reset the price after the show. What else? Any questions in the comments over on our... or questions or comments, I should say, over in our Discord, let me know. There's a nice picture of the board there if you want to take a look at it. And you can see you don't have to use Stemma QT for the I2C. You can also use the pins there if you want to solder directly to it or put it on a breadboard or a proto board. And it also does pass through I2C if you need another item on your bus, that's fine. This does, I believe, only have one I2C address, so you can't hook up multiples of them without using a multiplexer of some kind on a single microcontroller's I2C bus. Some of the microcontrollers, like the RP2040s, do have 2 I2C buses, so you could get away with that depending on your needs. What else? Am I forgetting anything? That should do it. Yeah, I think that does it for today. So why don't we wrap this up? I'm going to go ahead and unplug that, and I will just hijack my Stemma QT cable for the purposes of hanging it on the board for now. It is a good source for me of remembering where I have I2C Stemma QT cables. So that is my product pick of the week this week. It is the ENS160 MOX gas sensor. That is going to do it for Adafruit Industries. I'm John Park. Thank you all so much for stopping by today. Don't forget to head over to that page right there if you want to pick up some of these at the half off price for the next few minutes before the show is officially over and the price gets reset back to normal. Thank you so much, and I will see you next time. Bye-bye.